Welcome to this explainer. Okay, I need you to forget everything you learned about black holes in school because it's about to get turned completely upside down. Imagine the most destructive, terrifying force in the cosmos, right? A monster with gravity so intense it literally shreds stars. Now, take a breath. What if we took that exact same cosmic beast, completely neutralized the danger, and just popped it onto a lab workbench down the hall? Sounds like pure sci-fi, right? No way that's real. But actually it is. We're looking at a monumental scientific breakthrough here. Stick with me to the end of this explainer, because we're going to unpack how scientists are literally bringing the deepest, deadliest mysteries of space indoors. Okay, let's dive into this. What if you could extract energy from a black hole without ever actually going to space? I mean, that is the ultimate curiosity gap, isn't it? For decades, whenever we thought about harnessing black hole energy, our brains immediately jumped to those wild sci-fi movies. Massive Dyson spheres, deep space mining, spaceships dodging the event horizon. It always felt like a problem for humans thousands of years in the future, mostly because these things are millions of light years away. But what if the secret isn't building some impossible spaceship? What if the real trick is just bringing the black hole directly to us?
Section 1. The ultimate energy hook. An impossible contradiction.
Look, I know exactly how absolutely wild this sounds. Putting black hole and energy extraction in the same sentence feels like a massive oxymoron. How do you pull energy from something famous for letting literally nothing escape? To really get how huge this breakthrough is, you gotta look at the crazy contrast in scale. On one hand, you've got outer space. It's absolute zero, the gravity's crushing, and it's totally unreachable for hands-on experiments. But on the other hand, you have the laboratory. It's accessible, perfectly controlled, and hey, it's right here on Earth. The sheer brilliance of this whole thing is that we are just bypassing the impossible barrier of deep space entirely. We don't have to survive a cosmic vacuum if we can just recreate the math and physics right at home.
Section 2. Black holes and quantum physics. The science of the extraordinary. So how do we actually bridge the gap between unreachable space and a lab on Earth? Well, first off, we need to totally redefine our terms. When we talk about a black hole here, we are not talking about a cosmic vacuum cleaner eating planets. Nope. Instead, think of it as this massive, completely untapped reservoir of potential energy. Picture the very edge of a black hole, the event horizon. It isn't just a drain, it's a boundary that's absolutely buzzing with immense friction, gravitational waves, and trapped quantum particles. If you strip away all that danger of getting crushed, you're left with some truly fascinating physics. It's a localized area of extreme properties. And theoretically, if we understand those properties, we can tap right into that raw, buzzing energy. And that is exactly where quantum physics swoops in. Now, I know quantum physics sounds super intimidating, but let's break it down with a really simple analogy. Imagine water flowing down a drain, right? Eventually, it's moving so fast that a fish swimming against the current could just never escape. Scientists are doing something kind of similar, but instead of water, they use a one-dimensional chain of atoms. They create this microscopic waterfall where tiny particles, like electrons, are pushed past their own point of no return. By doing this, they effectively simulate that buzzing event horizon we just talked about. It's like the ultimate cheat code for the universe. Combining a black hole's massive scale with this tiny chain of atoms lets researchers recreate these extreme cosmic conditions safely. It's just a completely fresh, mind-blowing way to look at reality. Section 3, a laboratory black hole. Bringing the cosmos indoors. I mean, just say the phrase black hole in a lab out loud. It is genuinely breathtaking. Just take a second, let the sheer weight of that paradox sink in. A phenomenon so insanely massive it bends the fabric of the universe, and it's somehow being contained inside a room on a university campus. This isn't just abstract math on a chalkboard anymore. Major outlets are covering this because it's a physical space where vastly different worlds are literally colliding. But to be clear, if you walk into this lab, you're not going to see a swirling vortex of doom floating in the corner. You'd see a highly sophisticated, super cool chamber packed with lasers, sensors, and those microscopic chains of atoms we just talked about. Grounding such a wild cosmic concept in the everyday reality of a modern research facility, it just makes the whole thing even more fascinating. So, how do these two totally opposite environments actually interact? Instead of chaotic cosmic destruction on one hand and a super clean lab on the other, scientists are blending them together using specialized quantum materials. By manipulating that tiny one-dimensional chain of atoms, they create a highly accurate, fake event horizon. And here is where it gets absolutely wild. When they create this artificial boundary, the atoms behave exactly as they would at the edge of a real black hole. Researchers can actually measure the tiniest temperature changes in these atoms. They are effectively watching a miniature black hole glow from just a few inches away. They're pulling the universe's most extreme hostile environment into a controlled space where they can safely poke it, prod it, and figure out how it ticks. Section 4. Extracting the energy, the ultimate goal. Scientists just created a black hole in a lab without a black hole. That exact headline captures the absolute genius of this whole operation. Now, what's really interesting about this is that we aren't just simulating black holes because it looks cool. We are anchoring high-level, mind-bending quantum physics to one of the most basic, relatable human needs ever, the need for power. That fake event horizon allows scientists to observe something called Hawking radiation. Basically, that's energy literally leaking out of the void. You get all the observational benefits, all the math, all the energy extraction data, entirely without the minor inconvenience of an actual black hole destroying the Earth. If we can map out exactly how that energy leaks at the quantum level, we can theoretically figure out how to harvest it on a massive scale.
So the crucial point here isn't just a list of scientific milestones, it's a literal roadmap to a completely new frontier. First and foremost, no space travel required. That means we are saving trillions of dollars and thousands of years of travel time. This isn't happening a millennium from now, it's happening today. Second, it proves that energy extraction concepts driven entirely by quantum physics can successfully mimic the largest forces in the cosmos. And finally, it introduces a completely fresh topic to the public. This isn't just abstract academic theory. When we talk about securing a future for unlimited power, we're talking about finding an energy source so insanely efficient that it could permanently solve humanity's energy crisis. And it's all being unlocked by studying microscopic particles.
Section 5. The future of power. What comes next? Are we on the verge of a new era of quantum energy extraction? I mean, think about the incredible journey we've just taken. We started by looking at an impossible cosmic monster, a force of absolute destruction, millions of light years away. And we ended up looking at a microscopic chain of atoms inside a supercooled laboratory right here on Earth. Science never just stops at the simulation phase, right? Once a concept is proven, the next step is scaling it up and applying it to the real world. If scientists can successfully mimic a black hole just to study how it sheds energy, it really makes you wonder, what other extreme cosmic powerhouses can we put on a tabletop? It's just a beautiful reminder that sometimes the smallest things in the universe hold the key to unlocking its absolute largest mysteries. Thank you so much for joining me for this explainer. Keep your curiosity alive and keep looking inward to the lab.